Hey everybody, welcome to Bill Sky, the FORTRAN guy, and what we're going to do today is we're going to talk about multi-dimensional arrays. We're going to talk about single-dimensional arrays, but also multi-dimensional arrays. So I think we should just jump right into it. Arrays in FORTRAN. Alright, so let's go ahead and create a new project. And I like to use my templates. And let's see, well, we can use Intel. Let's use the G FORTRAN. And I'm going to rename this one arrays. Okay, so let's go in and edit our source code. And so the first thing that I want to do is I actually want to define the array. So right above here, I'm going to put in, you type in the data type. So it's going to be an integer array. You can use the dimension keyword, and you can specify how big it should be. Then you specify the name of the array. So I'll call this 1dim. Now, what an array is, if you don't know, an array is a set of data that is stored in memory, one item right after the other. It's called contiguous memory. And it starts at the memory label 1dim in this case. Each one is an integer, so depending upon the compiler and the operating system, the integer will probably be 4 bytes long. So an array of integers of size 50 would be 200 bytes long in total. So it allocates 200 bytes in memory. All bytes are right up against each other. They're not split in different parts of memory. So they're contiguous. And each item is accessed using the name of the array and then an offset, what they call an index, an array index. And so we'll take a look at that. I could create another one. I could create an integer array of size 10. And I can call this one result array. I could also create a floating point array of 5. And actually, let's fix that spelling, and I'll call this real array 1. So let's go ahead and save and build this. Let's bring up our terminal, go to the document location, and we can see it compiles just fine. Now this doesn't do anything. We haven't done anything with the array, but let's go ahead and do something with the array. So let's do something with our first array called 1dim. So the way that you access values in an array is using that index that I mentioned earlier. So let me go ahead and set the first item in the array to, I don't know, 999. So I'll say 1dim, parentheses 1, that's the index, so that's the first item. Now in FORTRAN, arrays start at 1. In C and C++ and Java, I believe they all start at 0. But in FORTRAN, they start at 1. And so I'll say 1 equals 999. Then I can say print 1dim1, so I can access the first item. Let's go ahead and save and build it. Let's run it. And you can see our 999 right there. Okay, that's real simple. Let's say I wanted to print off 1dim of 2. And I can go forever here. That's 3, 4, 5, 6. Now we haven't set those values, and I don't know for sure if the FORTRAN compiler initializes values in an array when you create it. I don't think it does, but it might. Let's go ahead and take a look. And you can see it doesn't. Some things are 0, and some things are these big long numbers. That's just garbage that's in memory. And that brings up a really good point. When you have an array in your program, if that array is going to have confidential data in it, secret data like maybe keys or something like that, you might want to zero those out before you actually leave the program so you don't have memory left over. This number right here, or part of it, might have been part of another program that was running in the same memory area. So if that had somebody's key to log in to their Windows or something, now the key's available in memory. So it's always a good idea to zero those things out. Now, as you can see, this right here can be very tedious, specifying every single item in the array using the index like this. So this will be the first time in this series that I've actually done this. We're going to use what we call a loop. So we're going to use a do loop to access all the values in the array. And so I'm going to say do, and you give it a variable name. I'm going to call this I, go from 1 to 50. And within that do loop, I'm going to say print one dim, and then the integer or the counter of the loop, and then I'm going to say end do. Now, one thing that you have to do in FORTRAN is you have to specify the variables outside of the loop. So I'm going to create an integer, and we're going to call this I. So what this loop does is it says, okay, I want you to initially have a value of 1, and you're going to go all the way up to 50. Now, why 50? Because of the size of our array is 50. So all of the indexes are 1 through 50. I want you to print the data in one dim at the location I, which is the counter of our loop. Now, as I mentioned earlier, every item in the array is 4 bytes. So if I say 1, doesn't that go after the first byte? 2 goes after the second, 3 goes after the third? No, the compiler actually takes the index I, multiplies it by the size of each item in the array, and then uses that as the offset. So let's see if this works. And you can see all of our data in the array. There's some zeros there, there's some garbage there. So now, how do we actually zero out every item in an array? Well, I'm going to use this do loop again. And by the way, since we're using that do loop, let's go ahead and get rid of all those prints. And let's create a do loop that's going to set every value in the array to 0. So instead of printing, we're going to say one dim of I equals 0. Let's save and build it. Let's run it, and you can see now every value in the array is 0. I can scroll all the way up to the top. Every value except the first one is equal to 0. Actually, the first one is equal to 0. This is the print of that first one that we set to 999, but in our loop right here, we went ahead and set it all back to 0. So I'm going to put a comment in here, and I'll put a comment here. You might say, well, it's obvious what I'm doing there. Well, you need to put in your comments. All right, let's make sure nothing I did caused a problem. All right, there we go. Okay, so that's how you can that's how you can set the values of the array. Now there's something else that you can do. I'm going to copy all of this code, and I'm going to say set each value of the array. And instead of 0, I'm going to say I times, I don't know, 12, whatever. And then I'm going to print it out again. So let's save and build this. And you can see all those numbers in there. So why did I take you through this? Well, it's a little bit of math, a little bit of arithmetic, where you can actually calculate something on the right side of the assignment symbol, which is the equal sign, and then assign it to each item in that array, and you can see those values. So it's 0. Now, it's always a good idea to do some kind of a print to separate your testing data out. Something like that. Because they're kind of, merging in with each other. Okay. And you'll see when we actually run this, it's going to be a little bit more obvious where your code did what. Because there is our comment right there. And there's our first comment. Okay, good. So that's some good comments in there. Okay, so what else can we do? Let's talk about two-dimensional arrays. So how do we create a two-dimensional array? Well, we simply come down here, and I'm going to create an integer array, and I'm back up at the top, and I'm going to make this, I don't know, 10 by 10, and I'm going to call this 2dim. Now, what does a two-dimensional array mean? A two-dimensional array is kind of like a spreadsheet. Think of a one-dimensional array like one row in a spreadsheet. Think of a two-dimensional array like an actual spreadsheet. And I'm actually going to bring up a spreadsheet here, and I have a spreadsheet on Linux called LibreOffice Calc. And you can see right here, this one row might be our one-dimensional array. You can see row 1. And so it's a little bit different because the columns are letters in a spreadsheet, but in an array, the columns are actually numbers. So you could think of an array, in this case, like the column. So our one-dimensional array, we'll call this array A, and every item in the array is a row or a cell in the array. Now, what about a two-dimensional array? Well, a two-dimensional array has both rows and columns. So, but in a two-dimensional array, the columns are not A, B, C, D. They're actually 1, 2, 3, 4. So in a spreadsheet, that'd be kind of difficult, right? Cell 1, 1. Maybe that wouldn't be difficult for you, but a little difficult for me. So I would go ahead and, so in a spreadsheet, you're going to use A's, or you're going to use letters for columns and numbers for rows. But in an array, you use numbers for both, and they both start at 1. But that's a two-dimensional array. Now, I'm not going to go into how arrays are actually stored in memory. If you're interested in that, Bill Sky, the assembly guy, that playlist, I actually have an overview of how arrays are stored in memory, and you can take a look at that. So what we've got here, we've got rows and columns, or you can think of them as columns and rows. So we have 10 columns and 10 rows, or 10 rows and 10 columns. It doesn't really matter how you think of it, as long as you stay consistent. So what I'm going to do here, I'm going to put a comment, 10 rows, 10 columns, just to remind myself. And let's go ahead and save and build this, and it built just fine. Okay, so how do we zero out? I would like to zero out every item in the 2dim array. So what I'm going to do to zero out every one, I could do something like this. And instead of 1dim, I could call this 2dim. And I is our rows, but what about columns? This actually won't work. If I actually save and build this, I actually get an error because the compiler says, hey, you have 2 dimensions. So I have to specify the first dimension, in this case I, and then I have to specify another variable. I could say 1, but that will only set the first column of every row to that number. Let's change it to 0. So you're only going to be updating the first column because we hard-coded a 1. What if I want to do it for every row and every column? Where this is where a nested do loop comes in nice. I'm going to say do j equals 1 to 10, and these should be 10. Why 10? Because we have 10 rows and 10 columns. And then instead of the hard-coded 1, we put in j. And then we also have to put in undo. So what's going to happen is this is going to run 1 time, then this is going to run 10 times, this is going to run a second time, this is going to run 10 times within that second time. So this is what we call the outer loop, and this is what we call the inner loop. So I'm going to save and build that. And I think we have a little bit of, oh, we didn't define j. We never defined the j variable. So we're going to come up here, and I'm going to say integer. I could have actually done it on the same, I think I could have done it that way. Let's go ahead and see if that works, which it does. Okay, so I and j. So I is going to increment the least many times. J will increment a bunch of times. J is going to increment 100 times. It's not going to go from 1 to 100. It's going to go to 1 to 10, then 1 to 10, and then 1 to 10 for each row of I. And now we can do the same thing here. I'm going to go ahead and copy this, and I'm now going to print it. So we're going to say print 2dim. Now, one thing I would like to do here, I'd like to print it like a spreadsheet where we have rows and columns. So the problem with print, though, is that print forces me to new line, to go to the next line. So what I'm going to do is I'm going to use the right in this case, and I want it to be 5 bytes wide, each integer. I'm going to say advance equals no, and then I'm going to say 2dim ij. So let's go ahead and save that and build it, and let's run it. Well, that's kind of good, except it's not really showing rows and columns. So what I want to do is I want to print, go to a new line at the end of every row that's printed. So let's go ahead and build that. Looks a lot better. Let's fill that data. Let's fill that array up with some random data. I think that would be kind of fun. And I haven't really talked about random data in this course yet. But let's go ahead and do it. So instead of zeros, I'm going to say call random number random real. Now I haven't created the random real variable yet. We're going to do it in just a moment. Now why random real? Well, the random number function, intrinsic function in FORTRAN always returns a real number, a floating point, and it's going to put it in there. So the call is going to say I want to call the function. The name of the function is random number, and I'm going to put it into random real. So let's go ahead and create our random real. So I'm going to say real random real. Okay. Now we put it in random real, but this is an integer array that we're dealing with. So what we have to do is we have to say random int, which I haven't created yet, equals random real times 100. Now you're going to see why I'm saying times 100 in just a moment. And then I'm going to say random int. So why am I doing this? Is I'm converting it from a real, multiplying it by 100 first, then converting it from a real into an integer. I guess I could have done this. I guess that would work because 2dim is an integer array. So let's see if that'll work. And it did. Now, why am I multiplying it by 100? Let's get rid of the multiply by 100 and let's see what we get. We get all zeros. Why? Because the random number function returns a real floating point with no integer portion. It's only a fractional. So what I'm doing here is I'm just going to go ahead and multiply it by 100 so I can get a few characters into the integer portion. If I want to multiply it by 1,000, I'm going to get larger numbers. I'll get smaller, but I'll also get larger numbers. So this is a way that you can actually fill your array up with random data. Now, why would you ever want to do this? For testing. You want to test to see how well your program is working, if it's able to handle that. Also, you can do something like this to fill up an array that might have had confidential or secret data in it with just some random number. So it's very, very useful for that. Okay, the next thing I would like to talk about are sections, array sections. And what I'm going to do here is I'm going to take my one-dimensional array, and I'm going to go down here, and I'm going to set it with a random number. So I'm going to go ahead and do the call. So I'm going to copy that call here. And then I'm going to say random real times 1,000. Let's build that. Built just fine. But I don't want to print off the entire array. I just want to access part of the array. So I'm setting all the data up there. Now let's go ahead and let's access, let's access the first half of the array. So I'm going to say 1dim of 1 through 25. I want to make that equal to 0. And then we're going to go ahead and print it. So what this syntax right here says, start at 1 and go to and including 25 and give that value, give that location in memory a 0 value. Let's run it. And let's take a look. And you can see all of those zeros. It's the first 25 zeros. Or should I say the first 25 positions of the array. I could do something like this. I could say 1dim 26 through 50. Make that equal to 99. And let's see what happens with that. If you remember, it just left the random values in there. And so now you can see the last 25 are equal to 99, and the first 25 are equal to 0. Also, what if you don't know the size of the array? Or let's say you don't want to have to hard code the size of the array every time. So what I could do is I could say one dim from 28 through nothing equals 100. So by not putting something in the second position right after the colon, it just means to the end. And you can see the 100, there's our few 99s there. So that's actually really nice. So this is a nice way of setting all values to 0 in this case. Now, if we come up here to the beginning where we set everything to 0 up here, what could we have done instead? We could have said one dim of 1 to 50 equals 0. And that makes just fine. So this one line of code is really nice because you can replace these 3 lines of code with that one line of code. Okay, now I've mentioned the size of the array. We're hard coding that in here quite a bit. Well, how can we do this without actually hard coding it? Well, one thing I'm going to do is there's a function called size. And let's see how this works. Size gets the size of the array so you don't have to remember what it is. So everywhere where you have the number 50, it might not be a bad idea to use that size function. And the reason is because what if I change the size of the array from 50 to 100? Now I've got to go into every single loop that I did this, and I've got to type that in. I've got to change the number from 50 to 100. This way you don't have to do that. You can just use the size function. Let's go ahead and make that. And it looks like it worked. Okay, another thing I wanted to talk about is going past the array. So let's do this. I'm going to say one dim of 51 equals 22. Now, if you remember, the size of the array is 50, but I'm specifying 51 here. Let's see what happens when I build this. I get a warning. It doesn't die. It doesn't end the compiler. It doesn't not compile. It compiles it, but it says, hey, you've got something past the limits of the array. What if I did something like this? One dim minus 10. Let's see what's going to happen there. You can see now we have 2 errors. It says it's outside of the bounds between 1 and 50. So it's going to tell you that there's a problem. It's going to let you run it. In fact, let me go ahead or compile it. If I run it, it looks like it worked okay, but I guarantee you it could be a problem. Let's say if I say 500 here. At some point the program is going to die. Well, it didn't die there, but it will, I guarantee it. And I'm kind of curious why it hasn't died. That's really interesting. Maybe if I put that up here, let's go ahead and put it up there. Nope, it still hadn't died. I got it to die when I was getting ready for recording this class or recording this video, but in this case it didn't die. So it will die. I promise you it will die. You do not want to do this. The compiler will not give you a warning if it wasn't going to be a problem. Okay. The next thing I want to talk about are array intrinsic functions. What are some of the intrinsic functions of an array? Well, first of all, one of the intrinsic functions is the size. This tells you what the size of an array is. There's also a thing called count. So what I'm going to do is, I set all these to 0. I'm going to delete that. And we gave our one dim a set of random numbers. I want to say I is equal to count of the one dim array all items that are greater than 100. So I will now get how many items in one dim are greater than 100, and I'm going to say print total items greater. Whoop. And let's see what we get. And you can see right here, total items greater than 145. And then the program ended. So that's count. Another thing you can do is I can say, let's do a max value. So I could find I equals max value of one dim. And then I'll change this to maximum value in one dim is, and you can use something other than the variable I, but I've got it there just because it's convenient. And the maximum value in one dim is 998. I'm going to run this again. 987, 986, 958, 951, 992. So that's really a nice function. There's also another one called minvalue. And that'll give you the minimum value, 43, 23. So really, really nice functions. There's another one where you can sum up the entire array in a single statement. And you can see the sum is changing, so that's sum. There's another one which is product. And we're going to actually see a problem here. We got a 0. Why is it giving me a 0? And the reason it's giving me a 0 is because I've overloaded it. I'm multiplying 50 numbers, greater than 100. So what I may do here, I'm going to say one dim, and I'm going to say just give me the first through the fifth. That's a section, so we can use sections again there. So it'll only do the fifth one. And it still is too big. It's awfully big. So let's go ahead and instead of 1,000, let's change this random numbers to only up to 100. And now we're at, we're still getting the product, we're still getting. So let's make this 10. And now we're actually getting numbers. So product is very useful, but you have to be very careful that you're going to be overloading, is that the right word? I think it is. Overloading the actual integer. Okay. Something else. There's a thing called all or any. So I want to see, I'm going to say, I don't really have a variable yet, but I'm going to create a variable called yes, no equals all one dim greater than 0. Now what is this going to do? This is going to return a logical, a Boolean, true or false, put it in yes, no, if all of the values in the one dim array are greater than 0. Now we have to actually create that variable. So let's go ahead and create it up here. I believe it's logical. So I'm going to come up here and I'm going to say logical yes, no. And then I'm going to say print yes, no. Let's go ahead and save and build that. And it says false. And that means that not all of the values are greater than 0. There must be a minimum value. And you can see right here, this actually should say minimum is 0. So let's go ahead and change this to minimum. Build this. And you can see the minimum is 0, so false. Let's do this. Let's say yes, no equals any one dim greater than 0. Are there any values inside of the array that are greater than 0? Let's go ahead and make that. And the answer is true. There are some values in the one-dimensional array that are greater than 0, and if we go up here, we can see that there are. Those are the reals. And I didn't print off that array after I set it up with random values, so you really can't see the example of that. I could just copy and paste that. Okay, so those are nice functions for one-dimensional arrays. What about functions for two-dimensional arrays? Well, you can actually do the same thing. The difference is that the two-dimensional array functions, they're going to return another array. So for instance, let's take a look at this array right here. If we want to get the maximum value of this array, let's say in one dimension, it's going to return the maximum value for each column in the array. And it's going to return an array. So it's going to return an array of numbers, one-dimensional array of numbers that's going to have the greatest value in each column of the array. So I'm going to go and create a result array. I believe I did. So here's a result array. My two-dimensional array is 10 in size, so it has to be the same size. So the result array must be the same size. So what it's going to do is it's going to look at that number, it's going to look at that number, it's going to look at that number, that number. It's going to find the greatest value and put it in the first position of our result array. It's kind of neat how this works. Now this is one of the real benefits of FORTRAN. It really was meant for scientific computing. Okay. So what I'm going to do is I'm going to say result array is equal to the max value of the two-dimensional array, dimension equals 1. And then I'm going to go ahead and print that. Let's save and build it. And here are our maximum values, 882, 588. Let's see if that's true. Oh, there it is. There's 882. There's 588. So for each column in the array, it's going to get the maximum value. And that's for the first dimension. If you said dimension 2, it's going to find the greatest value in each row instead of each column. So let's go ahead and do that. So I'm going to say print testing max val for 2dim by column. And let's do the same thing for row by row. And this time I'm going to say dimension number 2. So it does the column first, and then it does this dimension number 2 is for the rows. So let's go ahead and make this, run it. Okay, so let's take a look. So what is the greatest value in row 1? Well, it's 948. Yep, 948. Let's see if we got that. Yep, that's exactly what we got. We got 948. So it found the greatest value in the first row. And this is dim equals 2, the greatest value in the first row, the greatest value in the second row, and so forth. Really, really nice features. You can also do sum. You could also get a sum of all of the numbers. And I'm not going to use product because it's going to overflow, but we can also test sum. So I'm going to go ahead and say testing sum for two-dimensional by column, and we're going to say 1. Now the sum is going to also do the result array, and then let's go ahead and do the same thing by row, and let's change that to sum, change that to sum, change that comment to row, and change that dimension to 2. Let's save and build it, run it, and here we go. So here are all of the sums of every column in the array. Really nice. With a single statement, you can do that, which is why FORTRAN is considered a scientific programming language. And testing sum for two-dimensional by row. So each one of these is a sum of that row. Now, if you're wondering how accurate that is, the fact that we printed off the array right here should do it, and you can get out your calculator, you could sum all these up, and you could see if that first item in that result array is actually equal to the value of all those numbers put together, or if each column is that sum as well. So actually kind of nice. Now product is also doable, but the thing with product is we're going to overload it quite a bit. Okay, the last thing I want to talk about is initializing your array into some values, some initial values. So now you can do that up here at the very beginning, or you can do it down here. So what I'm going to do is I'm going to say, I'm going to create a small array. So I'm going to say integer dimension 5, small 1 dim. And I'm going to say that's equal to 1, 2, 3, 4, 5. Notice that syntax. It's a parentheses with a slash, and then it ends with a slash and a closed parentheses. Let's go ahead and build that and make sure it made it okay. Now, I don't like these warnings always showing up, so what I'm going to do is I'm going to comment out those sections where I'm going out of bounds. There we go. And I could go ahead and print that. Let's do that. So I'm going to do a do loop. Let's go to the very top of our output. Well, let's clear this out. And there we go. There's 1, 2, 3, 4, 5. That's how you can initialize them. What if I want to initialize a two-dimensional array? How can I do that? Well, that's a little bit more involved. So I'm going to say integer dimension 5, 5. We're going to call this small 2 dim. And this is interesting because we have to reshape the data because this is considered a single dimensional array. So we just can't put a lot of that in there. We just can't put more numbers in there. I'm going to say reshape. And I'm going to put two parentheses because the reshape is a function. 1, 1, 1, 1, 1. The ampersand means continue to the next line. So that's the first row. 2, 2, 2, 2, 2. 3, 3, 3, 3, 3. 4, 4, 4. 5, 5, 5, 5, 5. And then we want to end that, close the parenthesis, go to the next line. Oh, we have to say comma. This is the second argument in the reshape function. And we're going to say the shape of small 2 dim. Whoa, see what I mean? It might even be better just to write a nested do loop to do this. But what this is doing, it's saying call the reshape function. The reshape function takes 2 arguments. What is the data that you want to use for the reshape? That's that one right there. And let's do this the right way. That's that one right there. The second argument is the shape of the array. And what is the shape? The array is a 5 by 5 shape. So let's go ahead and build that. Okay, now let's go ahead and print it. So I'm going to print j equals 1, 5. And we're going to use the right. Oops. So let's go find that right that we did. There it is. There's my right. I can stop scrolling for a moment. And we're going to call this one, or the name of the array is small 2 dim. And let's put a print up here. Okay, let's build it. Run it. Let's go all the way to the top. Oh, let's clear it out first. Go all the way to the top. And there's our two-dimensional array. Now, we didn't do a print down here. I probably should have said print to get us a blank line. Let's go all the way to the top. And there's our initialized array. Now, one interesting thing about this is that when you initialize an array like this, using the reshape function, it's not going to do it based on rows, columns. This is not a row, and this is not a column. It's the opposite. So I know I don't like that at all. So what you could do to make this really simple, just go ahead and swap these. Make this a J, make this an I. And now it looks like rows and columns. It looks like you put all ones. And again, the idea of rows and columns, this is just a mathematical idea. It's not even real. So you just have to make sure that you're always going to be doing it this way. That J, the inner loop, is always going to be your inner, or is always going to be your row, and I is always going to be your column. So again, and I have never figured out how to do that, but I don't really like using the reshape, but the feature is there. Now you can use this function anywhere you want. Like let's say if I want to change the value, so I'm going to say small 2dim equals reshape. I could do this down here. 2, 2, 2, 2, 2, 3, 3, 3, 3, 3, 4, 4, 4, 4, 4, etc. So I could also do it this way. So I could do something like this. Let's build it. And we got an error here because we didn't finish it up. We didn't put in the 5s and the 6s. So we didn't actually specify it based on the actual shape. And now we got a good clean compile. All right, so that is our introduction to arrays in FORTRAN, how to access each one, some of the intrinsic functions that are built into the language. I hope this helped you out. It is a little bit different than other languages like C, C++, Python, or Java, but it's still a really great and very, very feature-rich array capabilities within the FORTRAN programming language. Hope to see you in our next video.